This is really funny, you know. This power supply worked so well for years and suddenly nothing happens. Kind of stupid because I'm using this for stage lights. Yeah, it was a kind of improvisation. I did that in a hurry, and suddenly when I was ready to start the gig a few days ago, no more stage lights. So let's start with the beginning, and that means we need to check the power supply cable. That's a simple test. Good and good. Okay, we are good to go there. Let's get on ohms, and nothing at all. That's the output. Do you think we have some voltage here? Let's check that before. Nothing. But yes, we have a capacitor, that's for sure. 263 ohms and back kilo ohms. Of course, the capacitor is discharging now because I just reversed the polarity. So, once again, the power supply, it's okay. We should have a green LED here. Let's see. No green LED. Nothing left but opening this up. Oh, I don't recall that I ever opened this power supply before. It was too easy. I can see we have a fuse there. Yes, you can see here, this one. Glassy stuff. That's a fuse. Let's check that out. We should have a clear beep from here to here, and no beeping. No beeping. So that means the fuse it's kaput. You can see very clear the glass, it's smashed too. But why do we have, let's measure this guy, diode mode. Nothing short here. Let's check the diodes. Oh, come on, shorted diode, I can't believe it. Let's see once again. I can't believe that. So this one and this one, these guys are playing short. Why? Do we have a, what's here? Okay, so this is a filter. It's used to, from here to here. This filter, it's used to lower the interferences, you know, the RF oscillation or anything like that. But it's looking like we have a clear short from this one to this one. How comes? Okay, so the schematic, it's looking something like this. We have the main 230 volts AC, and then it's looking like, so that's the input. Then here we have a fuse, and after, in parallel, we have this piece here, the yellow one, which I think it's a capacitor. It should be a capacitor. Some of the schematics have also a varistor, which clearly I don't see it around here, so I don't bother with that. And of course, from here it goes to a bridge rectifier, or in my case we have this 4 diodes. If the short is not disappearing, if I'm taking this capacitor out, which of course it's for RF problems and oscillation or something, then the problem is the diodes. But yeah, of course I forgot about, before the bridge rectifier we have these 2 coils. So here we have 2 coils, also for improving the RF radio frequency isolation and all the other stuffs. Okay, let me take this out. Okay, so one of the fits, it's in the air. Let's have a simple measurement to see how the things are getting. Okay, we still have the short, so this is really funny. That means we have a clear diode in short. I was really hoping it's just this capacitor, which by the way it's 0.47 microfarads. The capacitor, it's fine. I need a little bit of flux. I'm taking out this transistor because I can't unscrew it. Perfect. There we are. Let's clean the place and let's check now. Same story. I have this diode and this diode. So the whole wing here, it's shorted. Why should I take the diode out when I can simply cut the wire? Like that. Okay? That's so funny. Really, really funny. No more short. Very clear which is guilty for this problem. And to tell you the truth, you know, I never find this kind of blown diodes. That's funny. Short, that short. Man, amazing. Let me find two diodes. Here we have ER204, the one I could find. So 204 maximum peak, reverse 400 volts. Oh, super. What is this? Super fast rectifier. Okay, 400 volts. Perfect. And the other guy was 1N5399. Oh, that one was like 1000 volts standard. But I think 400 volts should be okay for this application. Okay, so let's put the diodes back. Yes, so probably I need some wires. That's funny. Perfect. Absolutely okay here. A little more. Perfect. This is good. Diode mode. Good. Perfect. Yeah. So I can clearly have the capacitor back. There we go. Perfect. Now let me have this guy back. Well, everything is back in place. The transistor and the heatsink, it's there. Also the capacitor is back in place. And as you can see, I have a new piece of wire here. So this is in fact the fuse. This takes the place of the fuse. It's a very thin piece of wire, so if anything wrong, it will blow in an instant. You shouldn't be too picky with rosin. Rosin, it's always a very good isolator and also mechanical fixer, if I may say. Okay, it's looking bright new. Before having the power supply on, let me check for any kind of shorts. I don't want to have surprises. Input, perfect. We should hear a beep because we have the capacitor. Yeah, of course. There's the capacitor. The fuse, it's perfect. No problemos here with the diodes. The output, any short, let's see. 256 ohms. That should be the LED on parallel. Yeah, we got this green LED here. And that's the capacitor, so the output. Shall we try to apply power? I have no doubt that everything is fine now. No doubt. Okay. 1, 2, 3, and nothing blows. Everything is fine. We should have the green LED running. Pam pam. There we go. Okay, volt. Let's check for the output. 12.7 volts. This is perfect. What I want to check is the voltage on this big capacitor, the input electrolytic capacitor. I want to be sure that we are not having more than 400 volts for the diodes, you know, to get blown. This and this should be the capacitor we have here, and we have 326 volts. Of course, reverse polarity. 326 volts, that means enough space for those diodes, 400 volts diodes, to work in the limits. You see guys, that's it for today. Everything is fixed, everything is fine down here. Don't hesitate to subscribe to my channel, push the like button. Thanks to my sponsors, and of course, don't forget, have fun. See you soon, bye bye.